Good evening and welcome. Good evening and welcome to this evening's event from the Institute of Engineering and Technology, North Wales Local Network. My name is David Crawford and I am chairman of the local network in North Wales. So yes, welcome indeed. And this evening we have 318 people online so far. So thank you everybody for joining us this evening. And it is indeed appropriate, I think, this evening to bring you this event, this webinar from Wireless in Wales Vintage Radio Museum in Denbigh, where I am both curator and trustee. So the event this evening, I used to work for the BBC in the transmitter department, and some 48 years ago in October, in fact, October 1973, I was, as part of my training, I was at Skelton Shortwave Radio Station in Cumbria. And on my very first day there, I was speaking to the senior transmitter engineer, and I was in his office, and on the wall was a chart. On the chart, there were transmitting stations and transmitters, and the programs that came from those transmitters at whatever time of the day, English, Russian, whatever. Now, there was Skelton A, where I was, Skelton B, for example. There was Daventry, there was Wooferton in Shropshire, not far from where we are now, in the Radio Museum in North Wales. Many places, various places, Ascension Island in the South Atlantic and Aspidistra. I pointed to the chart and said, what is Aspidistra? Okay. This evening, I'm very pleased, very privileged indeed to welcome our speaker this evening, Mr. Roger Castle-Smith, MBE, BSc Engineering, Chartered Engineer, Fellow of the Institution of Engineering and Technology. Roger was born in 1934, educated in Marlborough College. He obtained his amateur radio license at the age of 15, first station based on a Lancaster Bomber 114 transmitter and 115N 1155N receiver, call sign G3 IoT. Roger also built a TV receiver to receive the first BBC 405 line transmissions from Alexandra Palace. The kit was provided by Premier Radio in Tottenham Court Road, and some of you may remember Premier Radio in Tottenham Court Road, and it included a VCR 97 6-inch radar display tube. It was mostly XWD components. And Roger says, and I quote here, seeing the first somewhat distorted flickering pictures was magic to a schoolboy. From school, Roger attended Royal Military Academy in Sandhurst, set up an academy radio station using a Hallicrafters BC610 transmitter and associated receiver. From there, he graduated into the Royal Signals and has several very interesting postings in Germany and Singapore, mostly of a technical nature. He also enrolled in the Royal Military College of Science for 3 years to take an external London University honours level degree, BSc Engineering. Honoured with the MBE Military Division. Then at age 37, he decided to retire from the Royal Signals, mainly for family reasons and other reasons as well. And he joined the Diplomatic Wireless Service in the Professional Technology Officer grade. Roger worked his way up to become the head of broadcast group in 1979, then chief engineer and head of communications engineering department in 1981. Roger was honoured with the CBE civilian division, retiring age 66. And in retirement, he has a number of interests, including sailing and gliding. Now then, just before we start the presentation, there's one or two housekeeping things I have to tell you. First of all, Roger and I have timed the event. The event is scheduled to last for 2 hours. It'll actually last somewhat longer, maybe 2 hours and 15 minutes. Because of the length of this event, we're going to have a 10-minute break in the middle. We will play some music and show a picture as well. So you can go off and have a cuppa or whatever in the 10-minute interval. Now, I'm going to show the slides and Roger's going to speak. Now, in this event tonight, as I'm sure you can have already worked out, there are a lot of single points of failure. If anything goes wrong, can I ask you please to remain with us, at least for several minutes, until we try and recover the event, try and sort something out. At the end of the event, there will be Q&A, and we will also ask you for feedback when the IET send out the feedback request. At the end, I will also in the next few days send you all a CPD certificate and a survey as well that the IET have asked me to send out. This event is recorded and will be available. I'll send the recording to everybody as well. Okay, so thank you very much, everybody. Thank you, Roger. And at this point, I will now start to show the slides. So there'll always be a little bit of a gap while I set things up. So please just bear with me for a second or two while I go to share screen, start the presentation, and we will go to from the beginning. So you should have that. Have you got that, Roger?
Yes, 100%.
Good, excellent. Right, so we'll go to the second slide. There you go. Okay, Roger. Okay.
Okay, fine. Right. Just a couple of opening comments from me before I start in earnest. I will be mentioning the source of additional information as my talk proceeds, then various books at the end. So I suggest it would be handy to have a pencil and paper at the ready. Secondly, I have heard criticism of some webinars because the speaker has clearly been reading from notes from for some of the slides. I, together with our host, found it very difficult to know what to include or exclude from a long presentation, which could have gone on for a day. So I make no apologies for sometimes reading from my script to ensure that I cover the essentials accurately without including waffle, which would be a waste of time. Right, so now let's have a look at the agenda. The organization tree, just to be quite clear where the diplomatic wireless service fits in. Then on to Crowborough in Sussex, where it all started. Just a few essentials on amplitude modulation methods, because they enable transmitters to become far more compact. Then how does a listener know on what wavelengths to listen, radio times. Second transmitter station latterly became Orfordness in Suffolk. Then on to Cyprus, where we've had two stations at Ziggy, which was mainly, but not entirely, shortwave, and Ladies Mile medium wave. And then on to Madeira Island, which is part of Oman. I then go on to briefly mention 5 small stations in different countries, just to show the breadth of work which the DWS broadcast group had. And then, if you're further interested, I will just quote a few books which you might be interested in for the future. Right, so on the next slide, where the things fit in.
Sorry, Roger, I've got a problem. Hang on, everybody. I'm going to have to come out of the slideshow. I don't know why this has happened. Bear with me a second. Sorry about this, and my apologies. Entirely my fault. Do this again. Share. Right, try it this time. There we are. Yeah, okay. There you go, Roger. Yes.
Thank you. Right. The diplomatic wireless service was formed after World War WW2 from various communications elements of MI6, which included the political warfare executive. It operated as an independent quango. In 1972, the DWS was amalgamated into the administrative structure of the Foreign Commonwealth Office and was renamed, as you'll see on the slide, Communications Engineering Department. Communications Group, located at Hanslope Park near Northampton, was responsible for providing communications, radio communications with embassies for carrying diplomatic and associated traffic. Broadcast Group provided transmitters for carrying about a third, notice about a third, of the world and vernacular services of the BBC. The Prime Minister in 1986, then Maggie Thatcher, decreed that many government departments, which included the FCO, should divest themselves of non-core activities. This resulted in the BBC taking over the activities of the group. The official handover date was March 86, but it was not until sometime in 1988 that the transfer was complete, because there were a lot of technical things to be sorted out. Most importantly, the BBC did not want to take on additional burden, partly because it did not wish to increase the size of its engineering cadre. Also, the BBC was totally satisfied with the reliability and quality of the service provided by Broadcast Group. And I must say, for my part, I found that we got on extremely well with the BBC. I dare say some BBC people might be listening, but Bryce McCrick, the head of engineering, signed my application for FIET, and that was sub-signed by Bill Denny, who some of you may know. He was the head of engineering external services. The Broadcast Group comprised of very dedicated staff, most of them who knew each other as friends rather than just as work colleagues. This is perhaps reflected in a notice which appeared in the Times. Yes, it appeared in the Times announcement on April the 1st, 86. It read, and I use a somber voice, Broadcast Group, it is with the deepest regret that we announce the demise of the Broadcast Group of the Foreign and Commonwealth Office at 23:59 hours on the 31st of March. So I think that says it all about the dedication of my Broadcast Group. Right, the next slide, you'll think rather odd to start with, but I just wanted to put something in at the beginning to perhaps raise a little smile. BERS at the bottom stands for British Eastern Relay Station, namely Madeira. I will talk about that later on. But one of the engineers at BERS didn't really believe what they were being told. And what they really believed was that the BBC was trying to snatch the Broadcast Group from the Foreign Office. Couldn't have been further from the truth. So that engineer did this little cartoon, and it was sneaked onto the desk of the BBC's Director General. The Director General didn't think it funny. So he wrote a note at very senior level to the Foreign Office, and I won't read a copy of it because it's got some names in it, but a very senior individual wrote back to the BBC a very, very carefully worded reply and to explain everything. So now let's go on to something a little more serious down at Crowborough. Slide. So Crowborough in Sussex was, as I said previously, the headquarters of Broadcast Group. And during World War II, transmitters at Crowborough were used to transmit black propaganda and other material designed to upset the Nazi regime. Examples are included in the following slides, which I will come to in a minute. And the operation was carried out under the wing of the Political Warfare Executive. Programs for UK forces were included in between black propaganda sessions. After the war, the same transmitters were used to carry the BBC's world and vernacular services, and responsibility was transferred from the PWE, Political Warfare Executive, to the DWS. So how did the first transmitter come to be installed in Crowborough in Sussex? Now, this is an almost unbelievable story, but I got to know Harold Robin very well and had long chats with him. So what follows is absolutely pucker. Harold, who was a top Philco USA technician, was recruited into the political warfare executive. He proposed that a large transmitter carrying black propaganda and other subversive information would be a very useful weapon against the Nazi regime. This idea was put to the Prime Minister, Churchill at the time, of course, by Dalton, who served in the cabinet, with a note. He said, "I am not competent to judge the technical issues involved, but if the claims made by the author," that was Harold Robin, "I consider that we have here a secret weapon of great potency and that we should exploit it to the full as soon as possible." Now, I am very, very lucky to have the original copy of that letter, together with Winston Churchill's reply in his hand. And it simply said, proceed as you propose with the greatest urgency. Right, so we now come on to Aspidistra. And this transmitter was called Aspidistra. And David mentioned that you would find out later on, for those who don't know already, why it was called Aspidistra. The answer is very, very simple. It was named Aspidistra because one of the early programs included Gracie Fields singing the biggest Aspidistra in the world. It was shortened to ASPI-1, and then, of course, for further transmitters at Crowborough were called ASPI-2, ASPI-3, etc. So that is where the name came from. Now, how did Harold Robin get a big transmitter? And I have had to paraphrase this a bit because the story is very long, but I'll just give you an overview, which I think is fascinating. A gentleman called Crossley in the USA went into the radio game. In other words, he set up transmitters in the 1920s. When his son wanted one of those newfangled receiver gadgets, he could not believe how expensive they were. So, of course, the uptake was very small. He decided to build one himself from directions in a book and for a fraction of the cost. Soon he was making and selling absolutely astonishing numbers of little radios that people could afford. Since his receivers worked, simple receivers worked best on strong signals, he saw to it that his transmitter stations always had the highest signal strength, not the highest practical, and this is actually in a note from him, not the highest practical, but I want the highest possible, Somehow he finagled the Federal Communications Agency into an experimental authorization for what by the day was a huge transmitter, 500 kilowatts. And for the non-technical, that is equivalent, if you like, to the power of 500 one-bar electric fires, an enormous amount of power. A transmitter with that power had never been built before, and it was only achieved by the joint efforts of Westinghouse, the Radio Corporation of America, and many others. But, and a very big but, eventually the FCC put a lid on transmitters at 50 kilowatts. Crossley got involved in legal and other very expensive wrangles, but to no avail. So the transmitter was put into storage. It was discovered by Harold Robin, and he was instrumental in upping the power to 600 kilowatts before it was sent to the UK. And you can see the transmitter on this slide, and it actually consists of 3 transmitters, 200 kilowatt transmitters, which are connected in series. I mentioned just one technical point for those who know something about transmitters. I did say connected in series, and that is absolutely accurate. But Marconi later on, when they put transmitters together, favored a parallel connection arrangement, and there are advantages and disadvantages of both series and parallel, which is right out of court for the length of this presentation. Right, just one technical slide, the next one.
There's something wrong. I don't understand this, Roger. Apologies, I'll have to go back. Very concerned now. Hold on a second.
Oh dear.
Slideshow. Hang on. Right, we'll go to there. Front slide. Okay, try this. There you go. Right. Okay, thank you.
Right. This for technical people who know something about transmitters and valve amplifiers. This is 1/2 of the final power amplifier of Aspidistra. And there were two valves in each half of a push-pull arrangement, making a total of 4 valves. The anode is downwards with a cooling water jacket around it. On the center left with the arrow, cooling area being fed to the filament seals. And in the middle, the grid assembly. And near the top, there are 4 resistors in 2 groups, 2 in each. And these were balancing resistors to make sure that each valve in the half took its own fair share of the load. These valves were first used, of course, in the wartime, and they were still used right up until Aspidistra was closed, which we will come to later on. Because they weren't readily available, we had some of those valves rebuilt at not inconsiderable expense in the USA. Right, where was Aspidistra housed? Next slide. It was housed in a bunker, and Churchill made one further comment on this. It was regarded as potentially so important that it had to be put in a bunker which would withstand a 1,000-pound enemy bomb if the site was discovered. And the ferroconcrete roof was poured over a 3-week period. And the transmitter floor was about, 50 feet below ground level. That was the main transmitter, which you saw in a previous slide. And then the power supplies, cooling air, cooling water, etc., were on another floor below the main transmitter hall. So what aerial did Aspidistra use in the next slide? It used 3 aerials, a driven element, and behind it 2 reflectors, which were tuned at the bottom so that the beam could be altered very, very slightly. Beam angle could be altered very slightly. While they were being transmitted to, transported to the UK, fortunately, they were in 2 groups, and 2 of the aerials received the attention of a U-boat. So it initially went on air with just the driven element, and the 2 other elements followed on. Also, of the 3 transmitters, 2 were in one shipment and 1 in another one, but fortunately they arrived intact. The next slide. a little bit of a technical one for those who are interested. We see item A, modulation transformers. And let me remind semi-technical viewers, if I can put it that way, that a transmitter has a carrier power of, shall we say, that is unmodulated of 100 kilowatts. Then when it is fully modulated with program, that program has to have a power of 50 kilowatts, 25 kilowatts in each sideband. So those transformers were handling an awful lot of audio power. Item B was along smoothing inductors for smoothing the ripple on the DC supply after it had been converted from AC. And C, the original rectifiers for converting to high voltage DC were what we call ignitrons, and these had a very nasty habit of backfiring. That is, conducting in the wrong direction, which could cause a lot of damage to associated components. These were replaced after the war by military-controlled arc rectifiers, which some of you may know all about. And finally, when solid-state rectifiers became available, well after the end of World War II, they were used to replace the military arc rectifiers. And these are the rectifiers in diodes in yellow, just below the C caption on the screen. We now have to ask the question, well, where did the power come from? So we see in the next slide that the power supply in Crowborough was nowhere near enough to power the transmitters. They were partially modulated to start with, but still all the lights in Crowborough flickered, which didn't please the population. So Crossley, nothing to do with the Crossley earlier on, who produced all the little radio sets, but a completely separate Crossley. This is a Crossley engine which was bought, and it is two identical engines, one in the foreground, an alternator in the middle, and then another engine behind the alternator. And these were two flat 8 engines making a total of 16, 16 cylinders in total. They were blown supercharged, and one supercharger fan is on the middle left with a corresponding one on the right. Right, just a few details of that engine in the next slide for those who are mechanically biased. Up at the top, which I know you probably can't read very well, it's too small, but that is a extract from a log of the Crossley Company, and I was very lucky to find that existing still in an engine museum up near Liverpool somewhere. It was originally, the basic engine, you'll see 2,400 brake horsepower, but that was supercharged to take it up to, pressure charged to take it up to 3,190 brake horsepower. The alternator in the middle is described as a flywheel alternator because one of the things which went out from some of the BBC transmitters was a holding tone. And I will try and represent this, probably not very well, but boom, 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 boom. And this was, of course, a tremendous fluctuating load on the alternator. So the fact that it carried a high inertial mass helped to smooth out those big swings in power requirement. You will see near at the bottom that the due date for delivery was December 21, and it was almost ready at that date, but it wasn't dispatched because the building for it hadn't been quite completed. Right, so that covers the car. And in the next slide, we will see one of the very, very first black propaganda schemes, which was thought up by Harold Robin. Now, look at Germany on the right and see two domestic transmitters, rather like our home service, Deutsche Welle, and perhaps it was transmitting on F2 in Hamburg, and maybe on frequency 1 at the bottom in maybe Cologne. But an important thing is they were both fed from the same program source. F1 was received by Crowborough on the left. So when one of our bombers, or bombing raid, went across, as indicated by the little aeroplane, towards Hamburg, the station was always shut down to prevent Hamburg being used on F2 as a direction finding beacon for the bombers. However, directly the program shut down, the receiver in Crowborough on the left connected the program output to the Aspidistra on frequency 2. So that the locals then didn't know that they weren't listening to the original program, but rather were listening to what was coming from Crowborough. And then subversive information and other information was put in, but that couldn't last for very long because that also had to be switched off when the bombers got very, very close to Hamburg. Now, the sort of thing that one of the very first things, I believe, according to Harold Robin, that went in, and this was dreamt up by a gentleman called Sefton Delmar, who produced a lot of the black propaganda, and I'll come to Sefton much later on. But the sort of thing which Sefton dreamt up was, the government is very sorry that food is in very short supply in Hamburg, but it will be available at a food collection point at a given location. And of course, the locals got to the food collection point where it was destined to be, but there was no food collection point, which caused a lot of disgruntlement amongst the local. Right, there were many operations from Crowborough, not just Aspidistra, and I'll just mention a few of them because I think they're quite interesting. So we'll go on to the first one on the next slide, which was called the Soldier Sender Calais. A station apparently transmitting from Calais, but which was in fact a transmission from Aspidistra. It pretended to be a station of the German, and I am reading from my notes here, so I don't leave anything out. It pretended to be a station of the German military broadcasting network. But the actual transmission, as I've just said, was from Aspidistra. The method of propaganda used by the Soldier Sender Calais was described by Sefton Delmar of the political war executive as cover, dirt, dirt. That is using good music and providing coverage of sports and other events of interest to German servicemen, punctuated with propaganda. Now, it's made to sound real because our agents, in fact, sent back to the UK the details of the football matches so that the locals could then match that with what was actually happening on the ground and believe it. Then on the D-Day invasion of June 44, Soldier Sender Calais broadcast information that was intended to impress German intelligence that the invasion area was wider than it really was. After the Pas de Calais area was overrun, the station changed its call sign to Soldier Sender West. So that's one example of what went on in Crowborough. Another example in the next slide. Operation Dartboard. I don't know why it was called Dartboard. I've never discovered. Fluent German speakers gave false information to German fighter pilots to direct them away from Allied bomber attacks. As German operational procedures changed to prevent impersonation, so the British copied them by bringing in German-speaking women from the Women's Auxiliary Air Force operators when the Germans changed over to female operators. Right, well, the operation on Aspidistra had to come to a sad end, which we will see in the next slide. And those not involved with this sort of thing thought it was a little bit odd. This was just another bit of technical kit. But in fact, we had a very big closing down in party. And our own people were present, very senior people from the FCO, the Foreign Office, the press, etc., etc. And this is just one end of the transmitter hall. The next slide. I am, thank goodness you will say, the only slide which includes me, with my hand on my hip, giving an overview of Harold Robbins' history, which included his key projects. And this was followed by my invitation to him to switch off Aspidistra for the last time. And we see in the next slide, Harold being invited to sign the last transmitter recording chart. Now, it is not quite true, one has to admit, if any of my ex-staff happen to be watching, it is not true, actually, that it did close finally on that date. It was open for a few more weeks, or was it perhaps a couple of months, until we had got things organized in Orford Nest, which I'll come to later. Okay, then some more transmitters at Crowborough in the next slide, called the Atlantic transmitters. And these targeted U-boats with the objective of lowering morale and giving false information. Now, I have got on my file a whole list of different things which are transmitted for lowering morale. But I will give an example, just one example. Our agents in Germany got to find out the names of the submarine captains of various U-boat numbers. And one of the transmissions went like, something like this. Hello, U-boat 258. We are sorry to say that the wife of your captain, Herr Schmidt, has often been seen frequenting with several ladies of doubtful repute in a Paris nightclub. And then in the same transmission, most of the families of U-boat crews have been moved to Hungary in order to avoid the British bombing raids. Then a week or so later, it is regretted that many of the families who were moved to Hungary have died due to disease which is spreading rapidly. Russian doctors and nurses were flown in to assist, but there was nothing which they could do. Now, it is a matter of personal opinion whether that sort of subversive information should ever have been used as civilians were involved. And I certainly won't get into talking about that now, because there is very divisive opinion I've heard for both ways. Then on to the next slide. That's just a very quick, for the technically interested, a couple of the 100 kilowatt Atlantic transmitters, American transmitters. Nothing much to say about those, but I just showed that slide as a reminder of the Atlantic transmitters. Then we went on to, in the next slide, silent minutes. And this was an attempt to jam the V2 rocket guidance system. Intelligence experts had, by June 44, a very realistic and remarkably accurate assessment of most aspects of the V2. But they lacked detailed information on how it was to be guided. The story is a fascinating one for those who might be interested. Just Google for an excellent article on the subject by Pat Hawker. One of the requirements was to build a VHF, very high frequency transmitter at Crowborough with a view to jamming if anything could be found out later. And one problem that Crowborough had, they hadn't got any suitable valves to operate at that frequency. So they were sent across from America. And then a highly technical point, just for the technically interested, there was a problem with a coupling capacitor between two stages. They tried to make one up, which was unsatisfactory, but somebody had a bright idea and used the interelectrode capacity of one of the Aspidistra valves, a very expensive valve. Then they wanted some components for the power supply, which wasn't readily available. So it was decreed that the BBC, and I think it was from Wofferton, but it may not have been Wofferton, doesn't matter if that's slightly inaccurate. And one of their transmitters was raided for parts to make up the power pack. And the BBC were not amused. Then another project, on the next slide. Oh, I should just say, don't go back on the slide, just taking one other point on Silent Minute. Not only was that transmitter set up in Crowborough, but a monitoring chain was set up of receivers the whole way between roughly Deal and Ventnor and the Isle of Wight on various masts, trying to listen out for V2 guidance signals, which were never found. Sorry, yes, back to the Leviathan aircraft carrier. The government of the day wanted to be able to broadcast from anywhere in the world. So Harold Robin of Aspidistra fame proposed installing a transmitter on the decommissioned Leviathan aircraft carrier deck. A lot of planning was done, but in the end it was unsurprisingly abandoned. The cost of the transmitter installation and power supplies would have been trivial compared with the cost of running Leviathan, even at subsistence level. It was an incredible thought, but that was just typical of the gargantuan projects which Harold Robin thought about. Right, now on to amplitude modulation. Now, I'm going to suggest that those who are perhaps not technical don't get discouraged at this stage, and just any such people watching, don't bother to look at the next slide and the following 6, because after those 6 slides worth of technicalities, I will be back more into historical. Right, the next slide, a very simple diagram of amplitude modulation, no modulation, left-hand block representing the carrier wave, and 100% modulation, which required, as I said in an earlier slide, required an additional half the power of the carrier wave. Huge modulation transformers. So one of the very first things that we used by the broadcast group, in the next slide, was the Aspidistra system. This lacks many, many components, but it's only designed, this circuit diagram, just to show the very bare essentials in the time available. The power amplifier on the left with the radio frequency signal going in, output to the aerial, high tension power supply, typically 8,000 volts, and the audio program signal modulating the HT supply, which would give a double sideband signal at the output. Disadvantage, huge components. So then later on, slide, I need to put this slide up. It would be an insult to some techies, but others may need a little bit of refreshing, because this is essential to the operation of the next modulation system. We have got a quarter wave line, λ/4, with a characteristic impedance of Z0, and the equation linking the output and input is looking into the line, Zs, Z send, is the square of the characteristic impedance of the line divided by the receive impedance. So as the receive impedance went down, the sending impedance looking into the line appears to go up. Now that is critical to the understanding of the dirty modulation system in the next slide. Now it would take 2 or 3 slides to convince you all, I'm sure, about this. So I will only give an overview, and again, there's a lot about it on the internet. It was first dreamt up round about, as far as I can make out, round about the mid-30s, but it was first put into use by the Foreign Office, as we will see a little bit later on. We have the normal double sideband drive signal being fed to both valves. That's the carrier plus, of course, the sidebands. It is fed to VC, which is called on the left, the carrier valve. And for the moment, forget the -λ/4. On the right, the signal is fed into VP, the peaking valve. Now, when you've got carrier only, VP is arranged to be non-conducting, whereas VC is taking the entire carrier load, which is transmitted through the λ/4 line with an impedance of 2Z to the aerial output in the middle. Now, as the drive modulation starts to go positive, then VC carries not only the carrier content, but a bit of the sideband power as well. And the peaking valve provides the rest of the power. And that is possible because of the way in which the λ/4 line operates. I'm afraid in the time available, I can't be any more convincing, but that is the guts of it. And oh yes, the -λ/4 line on the left has to be there to compensate for the +λ/4, otherwise the 2 outputs wouldn't be in phase synchronization. Then we go on to the next type of system, which was used by AEG Telefunken and later on Marconi. And it starts off with the drive circuits with the program or audio in, converted to pulse duration modulation. And it would be an insult if I tried to explain that, because I'm sure it is very clear from the bottom 3 waveforms. Carrier only, the marked space ratio is clearly 1:1. Right, so that is applied in the next slide. At the bottom, you can see that a valve under the carrier condition with equal marked space ratio. The final amplifier at the top and a 10 kV power supply in the bottom right-hand corner. So let us assume, forgetting losses and other niceties, that we're after a 10 kilowatt carrier output. To give a 10 kilowatt carrier output requires 1 amp from the 10 kV power supply, 10 kV at 1 amp, 10 kilowatts. Looking now at the top, there is only 5 kilovolts available there because of the 1-to-1 mark-space ratio of the PDM belt. I'm going to pause now for a few seconds, and I hope that one or two of you at least will get a little bit hot and bothered about looking at that diagram. Yes, you will surely have observed that that doesn't satisfy Kirchhoff, because in one end of the piece of wire at the bottom we've got 1 amp and 2 amps at the top. So what is wrong with that diagram? Well, nothing as it stands, but we need to add a bit to it in the next slide. Right, you will see I've added a diode, and the additional 1 amp is supplied by that diode through the diode, rectified from the energy held in the smoothing circuit, the capacitor and the inductor, which smooths out the sampling rate of the audio. That became very widely used, and again, a few more components are needed. But if you want to find out more, just go onto the AEG telefunken site, which still exists. A lot of interesting information. No heavy modulation components at all. So, next thing I would now like to go on to is how did the listeners of the day know what programs were available, both in the World Service and in the vernacular foreign language transmissions. And this was all published in a booklet called BBC London Calling. And I've shown part of the inside of one of those in the next slide. Now, I know, and I'm often criticized lecturers myself, because they put up slides which can there's so much detail that they can hardly be read. But I excuse myself for doing so in this case, because I can explain very easily what is in that chart. The list of countries to which that chart applies, very clear, you can sure read that. Sorry, I saw a chat come up. I must ignore that, sorry. Yes, that chat comment was quite right, that there were transmitters, 30 transmitters in use quite considerably before the FCO. Back to the diagram, along the top countries, frequencies down the left-hand side, and then the bar charts comprising letters showed that when a particular transmitter was on the air, and letters, which you can hardly read on the bars, see, for example, for this transmitter in Cyprus. Right, so that is fine for the listener, but how did the transmitter stations know what should be on the air at what time, which we see in the next slide. And this is my second excuse. You won't be able to read all this very well, but well enough when I describe it. Across the top, transmitter names, Madeira, Cyprus, Orford Nest, and Madeira. And underneath, for example, Cyprus, there are numbers, and that's the service number or transmitter number. And then the vertical bars indicate the time when that particular transmission was going out, what sort of transmission it was it World Service, etc., etc. And quite often, you will see when there's look right in the middle of the diagram, that there's a little V shape in the schedule, and that will be a change of frequency or change of program. Now, the BBC wanted quite reasonably very fast frequency changes, which the old type of transmitters wouldn't give. And I recall seeing transmitters with a very long frequency change side when I was kindly invited to go around the BBC station at Daventry. And people from the BBC came to visit us from time to time. And there was what I can, from memory, only describe as a mini railway system for changing coils. And there were other yesteryear items which caught my eye, namely rotary converters, were for providing some of the transmitter power requirements. I think this was for filaments, but I can't remember accurately. The system used by many modern transmitters involved tuning a transmitter to all the frequencies which might be needed into a dummy load. For each frequency, shaft encoders recorded settings for tuning capacitors and switches for coil taps. So when a frequency change is required, settings for the new frequencies are recalled from memory, and fast servo motors and tap changer switches establish the required settings. Then only a small automatic adjustment to the final amplifier as the aerial on use for a particular program would have a slightly different impedance to that of the dummy load. So frequency changing became literally, and I don't exaggerate, a matter of seconds. And what I mean by a matter of seconds, 15 seconds from band end to band end. Okay, we will now go on to Orford Ness in the next slide. On the coast in Suffolk, and in the mid-70s, it was decided to move some of the Cobra facilities to another location. There were several local reasons for this, and ideally a coastal station was needed to make the best possible use of the signal over land. Despite a long search, nothing could be found on the south coast. However, there was an over-the-horizon radar station, which I'm sure a lot of you will have heard about, at Orford Ness. This was a joint USA-UK project with the USA leading. Its objective was to give early warning of missile attacks, and its code name was Cobra Mist. It was an utter and abysmal and very expensive failure. All sorts of possible reasons were examined by experts from different countries. Receiver deficiencies, arcing of earthing map crosspoint, etc., etc. But there were no firm conclusions, and the project was abandoned. So the building became available, and the transmitter, which was a program, of course, Aspidistra, which carried the world service in England, that service was moved on to Orford Ness, and on 1296 kilohertz, further transmissions, which was used for various BBC vernacular programs. It was not an accessible site, as we will see in the next slide. That was the only easy access to the island. And I must say, I think going to work every day on a nice, refreshing ferry, but perhaps not in the winter, was quite an unusual way of going to work. Now, the Cobra Mist building itself, in the next slide, was absolutely vast. And if you look at the left-hand end, you will see a lot of what appear to be piles. And indeed, the whole building was mounted on piles because the land was more or less at sea level. So that was deemed necessary to prevent against flooding. And onto the Cobra Mist aerials. Forget the tall towers at the moment, but the radial lines are all part of the, or remnants of the Cobra Mist aerials. And they could be configured in various ways to give a different beam angle. The 4 vertical masts were the new ones for the 648 kilohertz transmission. There are only 4 aerials shown there, but there was in fact a 5th one in that array, and out to the left. The coax from the transmitter building, bottom right-hand corner, was fed to a hut at the base of the middle aerial, and the phase and power amplitude required to give the required polar pattern was distributed from the central mast. And then central right, the aerials for the 1296 transmitters. Now looking inside the building, vast. At this stage, the 648 transmitter hadn't been installed, but in the middle center, 2 homemade transmitters by the homemade by a broadcast group. And if we go on to the next slide, here they are, totally homemade. They were often used on the same frequency, connected together, or they could be, which wasn't in the original planning, they could be used as separate transmitters with drive gear and program distribution between the 2 of them. Then on to the next slide, just a brief glimpse inside the turret transmitter. One of the valves, CY1172, on the left, and the bit near the center at the bottom with the arm sticking out to the left is the water cooling jacket. Up from that protrusion is a glass insulating tube to isolate the power supply from the water cooling circuit. And you can just see, roughly in the center, the coil, which is a part of the lambda by 4 network. Somebody, which I forgot to mention earlier on, but somebody might say, oh, Roger, well, it's all very fine calling that lambda by 4, but that's all very fine at the carrier frequency, but what about the sideband frequencies? Well, yes, the fact that wasn't lambda by 4 across the band, it obviously couldn't be. There was distortion, but it was absolutely tiny and certainly not noticeable on a radio transmission. Right. On to next slide, which is the AEG telephone transmitter. That was superb. And I don't say that lightly. I'm very fussy about transmitter design. That was superb in all respects: finish, design, operability, maintainability. It was there, AEG telephone. And in the next slide is the control panel. Not time to go into this in detail, but basically each of the pull-out modules perform the function. And when a particular switching on function was started, and there are a lot of them which had to be gone through in a high power transmitter, for example, start blast air, cooling air, start cooling water, low level drive, etc., etc. When function had been completed, a lamp lit, and then another one lit to say that the process had been taken from there on. So it was very, very easy that if the transmitter failed to run up to full power, where things might be hurting. I am going to digress with just one other little amusing thing, a reminiscence. I could do hundreds, but I have thought it would be nice to put in 1 or 2. And myself and a couple of others from Broadcast Group went across to AEG in Germany to see what they had to offer. And on one evening, they took us to a restaurant, And they said, would they like to go in the company car? Or, because some visitors like to see the Berlin Wall, would we like to walk along the base of the Berlin Wall? We opted for the Berlin Wall. Halfway along it, it was a bitterly cold night. I just couldn't wait to spend a penny. So the rest of my crew and the AET people formed a little semicircle round me, and I relieved myself on the Berlin Wall. So I thought that was that. But on the last day, the chief executive came in and he said what he was expected to say. Hopefully we will be have the contract, etc., etc. And we're delighted to come to England to explain anything else if you wish. And then finally he said, by the way, I applaud your chief engineer, Roger Castlesmith. I really do, because he peed on the Berlin Wall, and that is exactly what we felt about it. So that was a very nice smile. Right, we will now change country completely and go on to Cyprus. Now, I had a problem with explaining how Cyprus came into being because I've got about a 14-page write-up by an Arab who used to be there. But it is fascinating, so I have tried to condense it. And if I try and remember that condensed version, I am bound to get it wrong. So this is one instance. I make no apology for reading from my synopsis from the original. Sharqul-Adna, S-H-A-R-Q-E-L-A-D-N-A, Sharqul-Adna, which means the Near East, started broadcasting in Arabic in 1941 from Jaffa, Mandate of Palestine. It was fully financed and run by the British government, nothing to do with Broadcast Group. The goal of the broadcast was to entice Arabs to join British and British-backed military forces, as well as to maintain political and economic stability in Palestine. They were also started as an answer to similar propaganda radio stations broadcasting in Arabic, set up first by Mussolini and later by the German Nazi regime. In addition, the British also looked beyond World War II as they wanted to retain an influence in the Middle East, where oil had become discovered in the 1930s. The details of the station altered several times, as did its location. From the beginning, the identity of the station's owner and operator was a secret. Officially, Britain had nothing to do with it. As late as 1948, in response to a parliamentary question, the Foreign Secretary denied that the station was run by the British Foreign Office. Instead, he claimed that it was operated by a group of people connected with the Arabs. Just before the British left Palestine in 1948, the station was moved to a site near Limassol, and many of the Sharqul-Adna staff moved with it. It seemed to be aiming to make the program as popular as possible, thereby attracting advertisers. In the early 1950s, the audience size increased greatly because the station started transmitting on medium wave, and such cheap medium wave receivers were much easier to acquire than shortwave receivers. Its association with the British was not a secret to the observant listener. The transmitting facilities were moved to Cyprus in 1955. In other words, those which eventually came under my wing. And early in the Suez crisis, it was revealed that the station was under the control of the British and was renamed the Voice of Britain. It started broadcasting anti-NASA news and messages asking civilians to keep clear of military targets. Finally, the station was turned over to BBC Broadcast in 1957. there must be hundreds of interesting stories like that on wartime history, technical and otherwise, which most people will never ever see. Right. The first station in Cyprus, which was part of the station moved from Şarkıladna area, in the next slide. I regret that I hadn't managed to find an extra slide. Sorry, a better picture than this. And my only comment was that in modern times, that sort of installation would have given the health and safety executive apoplexy. It could almost have been a grand version of what Marconi used for transmitting across the Atlantic. Right, we then come on to Cyprus map. There were two stations, which I put in at capital letters, one called Ziggy, which was almost all a shortwave station, but not entirely. And then Ladies Mile was a medium wave station. Ladies Mile, some people might say, well, you know, how on earth did that name come about? Well, it was part of these in the sovereign space area, and an officer in the sovereign base area had a horse called Lady, and each morning he rode the horse up and down the beach for about a mile, hence Ladies Mile. Right, so onto the Ziggy medium wave site now. And this was a mixture of medium and short wave, primarily short wave. And onto the transmitters. These were replacements for original Marconi 100 kilowatt transmitters. And rather like Aspidistra, the 100 kilowatt old transmitters had given very faithful service, but they were difficult spares-wise, unnecessary power drain because of inefficiency, and very long frequency change times. So these, in fact, were two shown here, 4 Marconi transmitters, which used the same, what I've called pulse duration modulation system as the AEG teleconference system. Now, there are various things which I didn't like about those transmitters, not timing to go into them all, but one was the run-up sequence. Very difficult to find out if transmitter didn't run up to full power. Far too many micro switches, which were a pain in the neck, and several other things. So I said what I would like to see. Well, of course, they said they couldn't and make all those changes. But some may remember that Lord Weinstock was brought into Marconi to sort out their woes, and he wanted them to have all the business which they could get. And he simply said to the design team, design what Roger wants. Not the FCO wants, design what Roger wants. Well, I wasn't a popular bunny at all, but in fairness, the design team, Marconi, went a long way to what I wanted to see, hence those 4 transmitters. There were, in fact, as well as those transmitters, 2 50 kilowatt Marconi, 7.5 kilowatt RCA, 50 kilowatt Continental, and other, what I would call small fry. So, how was Cyprus configured on the block diagram basis? In the next slide. There is a unit at the bottom called APSU, Automatic Program Switching Unit, which I'll come to later. And the program input to the transmitter, roughly in the middle, could come normally from a tape recorder, which is in the top right-hand corner, because all program was delivered on tape, no satellite in those days, etc. Or program could be taken from another shortwave station in an emergency, not ideal, but receiver's top corner. Any announcements? Tone for tuning, announcements and jingles such as boom, 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 boom. Then on the right of the transmitters, selection of the appropriate aerials. So how was all that automated by APSU? On the next slide. On the left is a time clock and various other things. And on the right, what looks like a horrendously complicated plug board. And each of the little white plugs could either be a short circuit, an open circuit, a diode one way round, or a diode the other way round. And then vertically and horizontally with time and aerial entries, etc. So that determined the programming for one particular schedule. Now the schedule typically changed twice a year, very occasionally more, but normally twice a year. And at that time, you did not have to reprogram by taking all the diodes out, all the pegs out and putting them back into different slots. But the logic of the whole panel was changed from positive to negative. And that picked up the new requirements. Now, that is difficult to understand in detail until one sees a detailed logic diagram, but I just wanted to put it on the map because I thought it was a very clever in-house development. But when the microprocessor came along and PCs, etc., of course, all that was replaced by computery. Then in the next slide, nothing much to say, but if something was apparently going wrong, or somebody rang the station up, perhaps to say they weren't receiving when they should be on a particular frequency, then this is a status diagram going from the left to the right, showing frequencies used, aerials in use, transmitters in use, etc. 52, slide, next slide. A very simple diagram. Transmitters on the left, which could be for tuning and fault finding, could be switched into a dummy load. They could be switched to a number of aerials on the right, or in the center. Most, no, not that's untrue. A lot of aerials were double-sided, comprising a curtain array, which is a reflector, and then arrays of dipoles on either side, so that by flicking the reversing switch over, you could switch the transmission direction through 180 degrees. And then on the right, a dipole stack was typically 4 dipoles high by 4 dipoles wide. But it was possible to put in a little extra length of transmission line in some of the stacks or the horizontals. And that slewed the array by several degrees, and you could do this to a limited degree without getting too many side lobes on the aerial pattern. Now, there's showed the reversing switch, looking at that reversing switch in the field. My fault. My fault. Yes, that's absolutely right. These were the feeders from the screen feeders from the transmitters to an aerial switching unit. And we see that aerial switching unit in the next slide. Very big building. The transmitter, all the transmitter inputs on one side. And then on the 2 adjacent sides, the switched outputs to the aerials. Looking inside the building, some people will say, ooh, ah. This was quite an arrangement which was designed and largely built in-house, although some external help was used. And the arrow, yellow arrow, near the bottom left, shows one of the drive motors which drove the switch, which is immediately above it. And then the green arrow shows that you can put that there are swinging links, two swinging links in one of the feeders. These served, in fact, two purposes. Either you could put another aerial switch in there, or alternative, they were used to, and I'm not going to explain this to non-techies, it would take too long, but for those in the know, they could be used to tweak impedances to get the best possible voltage standing wave ratio. All the positions were not equipped with switches, nothing like all of them. That would have needed a huge number of switches, something like 150 switches. So only those were installed which were required for the existing schedule and maybe some for the next schedule, but those could easily be rearranged if required. And then in the next slide, yes, a typical, my fault, I jumped my notes. A typical aerial array showing, very difficult to see in that picture. I've got a better one later, but you can see quite clearly some of the dipoles in the top right, and vertical feeders in the area of the Union Jack. And then when you've got a reversible array in the field, next slide, there's a reversing switch. So that just altered which side of the aerial was fed. 147 degrees on the diagram in the switch up position, and 147 plus 180, 327 in the down position. I spoke about how the power was generated for Cobra. So we now need to see how the power was generated for Cyprus in the next slide. The power supplies in Cyprus were pretty reliable, but it was decided to put in one generator so that if the power did disappear for a while, then at least what were considered to be the most important transmissions could be kept on the air. Some of you might recognize the Napier Deltic engine on the right, which was used in Deltic British Rail locomotives, a generator in the middle, and a compressed air bottle on the left for engine starting. Right, then that is the end of the medium wave station. We now go on in the next slide to the British Eastern Mediterranean relay station, Ladies Mile, and there were just two transmitters. Next slide. One of them is visible here, and they were exactly the same as the transmitter, the dirty transmitters in Alford Ness, and the other one is out of view. And then the aerials for Ladies Mile. Next slide. And there were two lots, one for each transmitter, of arrays arranged in a quadrilateral format, which is easy to see. And the feeder arrangements could be altered so you could have a change of direction in 90-degree increments. And then the feeder to the other four aerials, to the other transmitters, is very plain to see. going from the transmitter building in white, the feeder going along on supports just above ground level. Right, now, my voice is starting to get a little sore and I need a little water. And this is the time in which we will have the 10-minute interval, comfort interval, or call it what you may. And we will start again by going to Madeira Island with the Madeira Island caption after the 10-minute interval. So back to you, David, to control that interval.
Sorry, I pushed the, I missed the place to push. Anyway, no, yes, thank you very much, Roger. Thank you indeed. And yes, very interesting. And as Roger says, we're now going to have a break of 10 minutes. So we can have a cuppa or have a rest for a moment. In that 10-minute period, we're going to play some music. It'll take me maybe half a minute to get it set up. So we'll see you back in 10 minutes. Okay, thank you. I'm doing very well with this, am I? Sorry, but try again.
Don't worry, it happens to all of us.
Let's start this time. Yes. Right, welcome back, everybody. And sorry about a little bit delayed there. It might be nice and warm where you are, but it isn't nice and warm where I am. Good. Okay, so just been looking at a lot of the chat that's coming in, and clearly people are enjoying this presentation. I'm very glad. Thank you so much, everybody. Thank you. Now then, I'm going to go back to sharing the screen again, and we're going back to Madeira Island. So if you just bear with me a second, and we will come back to the presentation. Can you just bear with me a second, please? I'm just going to do a change here. That's it there. Rather take my time with this and try and get it right. Here we are. Good. Okay, then. So we'll now go back to Madeira Island number 60. Here we are. I think that this is correct, Roger, yes? Yeah.
No, I haven't got Madeira caption.
No, okay, I'll go back one then if I can. There you are, yeah.
That's it. Yeah, that's fine.
Yeah, thank you very much.
Right. Welcome back. As with Cyprus, the background to the formation of the station on Madeira Island is quite complex, but not quite as complex as Cyprus. So I will just outline it to complete the picture to see why we went into Madeira. In 1959, well after the end of the war, Harold Robin was in charge of the construction of the Eastern Relay Station at Berbera in British Somaliland. It had a 1500, not a mistake, 1500 kilowatt Marconi medium wave transmitter and a diesel power station. At that time, this was the largest transmitter of its type in the world. In 1963, the Somali government broke off relations with the UK, and the station was dismantled and moved lock, stock and barrel to Perim Island, not far from Aden, in fact, just a little bit south of Aden. A temporary low power station was erected in Aden, whilst the main station was rebuilt. The Perim installation was badly damaged by a power station fire in 1966. And because of the unstable political situation in Aden, the transmitters and aerial towers were recovered to the UK. They were refurbished for installation on the then new site on Madeira Island, which is shown, and don't want the next slide yet, but which is shown on the next slide in a moment. Those who know anything about the Deltic or mechanical in any way might like to be interested in why that fire was called. The station was got launched into service in a hurry at the request of the BBC, not unreasonably. But shortly after it went into operation, there was a nasty noise coming out of one of the Deltic engines, which there was one in Cyprus. And they inquired from a mechanical group back in Crowborough what they should do. Bearing in mind the political requirement for the hurry to get the station back on the air, the view was do nothing, carry on. And it was not long after that there was an almighty bang inside the diesel. Bits came flying out and the fire started. Why did that happen? Well, some of the early Deltics had two-part pistons, and the piston crown had a nasty habit of detaching itself from the piston skirt, and that's exactly what happened and which caused the fire. I think there were a lot of very unfortunate and bleak faces after that incident. Right, so looking at the island layout on the next slide. Just where is it? Madeira Island, very small island, roughly a mile across at the top end. And from Judgment, I suppose 4 or 5 miles, maybe a little bit more from north tip to south tip. So we had 2 stations there, a medium wave station and on a separate site, a shortwave station. So on to the medium wave station. The medium wave station is in the roughly top middle of the picture, with north to the left. On the right out of the picture at the bottom is the Omani Air Force station. In the middle, jutting out at the bottom, a jetty for supplies, and the fuel supply tanks, which were shared between the RAF, the Omani RAF, and ourselves for diesel oil. And the pipeline going from the tanks to the BRS station can be seen quite obviously towards the, from the middle to the top of the island on the left. How did one get to the island? On the next slide. Sorry, yes. How did one get to the island? On the next slide. I jumped the gun then, my fault. So the ferry. That was the only means of sea transport. But as far as passenger transport was concerned, station staff, then we were allowed to use spare capacity in the Omani Air Force planes, which can either be a Hercules transporter, a Skyvan, tiny little turboprop, or a very small airliner. Then the accommodation, which we see in the next slide. We had a mixture of UK staff and Pakistani staff, and Arabs, which I'll come to in a minute. But the UK accommodation is in the middle, the V-shaped line of bungalows, and the Madeira appointment or posting, 6 months or occasionally a year. It was one that staff either loved, one of those postings that they either loved it or hated it. Just below the V-shaped UK buildings were Pakistani accommodation. And at the bottom, the transmitter hall, generators, and a little swimming pool. Then the next slide, on station staffing. As I've already briefly mentioned, we had broadcast group staff who were responsible for maintaining the equipment and dealt with any technicalities. Pakistani staff were employed to run the transmitters, but not involved with technical aspects. And Omani staff who were responsible for domestic work, for example, the laundry, assisting in the kitchen, etc. There were some characters amongst that lot. So what transmitters were there? In the next slide, there were the refurbished Marconi transmitters, as I explained previously, which came from PIM, 2 medium wave transmitters, and a small part of the second one is only just visible on the right. Transmitter final amplifiers, next slide. Not dissimilar to the Aspidistra final stage. 2 pairs of valves in parallel push-pull, very conventional, so nothing much else to say about them. What aerials were used? There were 2 aerial systems, one for each transmitter, a driven mast in the middle with a reflector and director. And if you look very closely at the center mast at the top, you will see a tiny little dot. And that is, in fact, to reduce the tip potential to atmosphere, to reduce losses by the production of corona. What about power generation on the next slide? There was no Commonwealth power on the island at all, so it had to be generated. And there were 5 Paxman, 5 1-megawatt generators driven by Paxman 12 YLC. For those interested, Paxman 12 YLC diesels. And there was also a 6th generator powered by a Napier Delta again to allow for maintenance on the main generators. There was no Commonwealth fresh water on the island. So in the next slide, you will see that we had to generate or produce all our own fresh water. And each generator was associated with a desalinator, one of which you will see in this picture. And that used waste heat from the engine cooling and exhaust system to provide the desalination energy. We then move on to the shortwave part of the station, which was about 5 miles further south. Again, British Eastern Relay Station shortwave. And a look at the outside of the building. Nothing very thrilling, but very, very isolated on the sandy patch. And you will see on the tower, which is coming up from the right-hand end of the building, you can just see Yagi aerials at the top. And those were used for receiving program from the medium wave station for onward transmission on the 2 transmitters. Power from the station came from the medium wave site via a copper line on poles. And an intense irritation to start with was when the Arabs discovered that we had a copper line between the 2 stations, and the copper was really quite valuable. So they threw a chain over the power line, roughly halfway between the 2, took the copper, and by the time we got there, of course, it was too late, they had all gone. But lots of words with the Wally, that is the local chief. We eventually managed to get that, thank goodness, stopped. What transmitters were used at that station? In the next slide. 2 American transmitters from the Gates stable, GATES stable. Thank goodness those were decided on before I came on the scene, because they were a pain of trouble. 2 main problems were that the great deficiency in the cooling circuit, and the second was a problem with the mechanical drives from servo motors to the various components. And the next slide gives an example of a problem. That is one of the final power amplifiers cut open. And you'll see at the 9 o'clock position on the left on the anode, part of the anode has melted and is dripped down onto the grid mounting plate onto the right, which is also very clearly visible. So each time that happened, in prices of those days, goodbye dolly grade to about £7,000. They could have got Gates to do something about it, but of course, being in the desert, the BBC wanting no program breaks, etc., the broadcast group got busy, redesigned the whole of the cooling circuits and the mechanical drive circuits, and all after that was well. That's the air laid melt. And then the aerial, one of the aerials at the shortwave station. I shown you previously some curtain arrays, but I've included this one because it's the best one I've ever managed to get, because it very, very clearly shows on the right the curtain reflector wires, whereas on the left, one of the 4 stacks of dipoles with the insulators, which you can clearly see in the middle. If any aerial maintenance required, well, one requires a standby aerial in the next slide. A lot of you, of course, will recognize this as a log periodic aerial. For the non-technical, the straight dipole arrays would only accept a small range of frequencies before you started getting unwanted, unacceptable side lobes from the aerial. But a log periodic aerial, although it hasn't got such a great forward transmission power as dipoles, it does have the advantage that without generating too many side lobes, it will accommodate roughly 1.5 octaves worth of frequencies. The small mast beside the main mast is what is usually called the gin pole. And from the top of the gin pole to the main mast is a block and pulley system used to lower the main aerial for maintenance purposes. I showed you earlier on how programs were selected in Cyprus in the main unit by means of APSIO, but this wasn't worth it for just 2 transmitters. And in the next slide, all the aerial switching, transmitter selection, etc., was done on the manual panel with switches at the bottom left, and then the various aerial configurations, which are shown top left and top right, with the switches on the down the middle, and program sources bottom right. And that was entirely manual, but for the amount of work involved, it wasn't worth going further. Eventually, you'll see in the next slide that satellite stations became available at a reasonable cost. So now we bought a Marconi satellite terminal, which is in this diagram, which was used for receiving program, both for the shortwave transmitters and the medium wave transmitters at the other site. Unfortunately, a hurricane hit Madeira, and the first slide is a reminder of that fact, and then some pictures of the damage which was caused. That's the feeder to one of the transmitters. It was not put like that with the broadcast group staff originally. You can see how much sand has been scoured away from the mounting blocks. A very dejected looking dog. There were lots of rats around the station. So that dog was named Cedric, Communications Engineering Department, Rat Catcher in Chief, Cedric. Another damage picture in the next slide. As you can see, a huge amount of damage to the aerial system. Bits of it were recoverable for jury rig, but not very much. And then on to the next building, the source building, which was used for both transmitter spares and domestic stores. Didn't survive. But fortunately, the transmitter building and the generators weren't too badly damaged. Now that station was got back, and I can't give you precise figures, I would be exaggerating, but it was got back on commendably double quick time. And I think we were only talking about a period, at least for jury rig, of about 2 months. And that was largely because of the dedication of my broadcast group staff, who when that happened, their one aim was to get the station back on the air and not start worrying about overtime, etc. That's the sort of organization which I was very pleased to have underneath me. The next slide, I discussed with David. I didn't think I should put this in, but he thought it would be of interest, so I included it. This is, the white is called aslan, that's an insulating material. And that was taking the kayak's feeder into the hut at the bottom of each driven mast. That is 1/4 of the panel, with the center of the coax going in through the bottom right-hand corner. And the 2 dots at each corner of the top are in fact screws which screwed the panel into position. Now the aerials were absolutely bang on the shoreline. So when we had the hurricane, that of course blew an awful lot of salt water everywhere. The panel became surface conducting, and that flashover occurred, which is rather pretty. CED art at its best. And I have got that hanging up right beside me in my study. Of course, with hindsight, what should have been done is that should have been designed as a round panel with clamps right round the outside, non-metallic clamps round the outside, and the feeder going in through the middle. Well, now, that in fact is the end of the Madeira story. But again, I wasn't sure whether I should include the next 2 or 3 slides. But David suggested that this would be welcome as a slight deviation from the straight path, although it was really part of the broadcast group. My last trip back from the, thank you, that's fine. My last trip back from Madeira, one normally stayed in the Intercontinental Hotel in Muscat to connect with a flight the following day. So I tried to book into the Intercontinental and was told that my booking had been transferred to the El Bustan Palace Hotel. Well, I knew nothing about that. So I rang up the embassy, and in the embassy, which I hadn't explained, we had an admin officer who was responsible for food supplies to the stations, etc., etc. He made some inquiries and said, yeah, that was quite right. But it had got to be known that this was my last trip, and the Sultan's Palace had decided to transfer my booking to the Al Bustan Hotel and hoped that I would like it. So if we go on to the next slide, there is the hotel top left-hand corner. And in the foyer, I should explain one thing first. Roughly every year, each of the Gulf states took it in turn to host the Gulf States Conference. And on this occasion, it was Oman's turn. And in the foyer of that hotel, there was a big brass plate with a bit in Arabic and a bit translated into English. And it said to the architect, build me the finest hotel in the world. The top right shows its position. You can just see a little jetty going out. It was sorry, beg pardon. You can just see a little jetty going out. And if you go vertically upwards, you can just see the hotel. The setting was magnificent. And the fluorescence in the water at night was just seen, had to be seen to be believed. There was no road to that hotel, so to have it built, a road had to be blasted through the mountains especially for it. Bottom left is the entrance area. And you can see, if you look at the chandelier-like lights, there's a multifaceted gallery. And off each of those facets was a room, which was for one of the representative from each of the Gulf states. When it wasn't occupied, which was most of the time, except for one or two dignitaries who occasionally visited, you could see through a plate glass window everything that was inside. And of course, when it was occupied, shutters came down. And each of those rooms was incredible. It was individually furnished. And for one of them, it was ancient, it was on classic, sorry, beg your pardon, it's not the word I wanted, antique English furniture and various other themes for the various other rooms. The dining room, one of the many dining rooms, bottom right, but there were lots of small dining rooms for individual parties. Now, one could order one's meal in advance or look at the menu. So I ordered my a meal, a lunch meal, and you could have it in one of the restaurants, name one of the restaurants, or have it on the pond. So I naturally assumed on the pond meant that I would have a nice table beside the pond with a chair. Next slide. But oh no, on the pond meant on the pond. And the depth of the pond was roughly at waist height. And there was the floating basket of my lunch meal. I've never met anything like that. Now, I just want to finish off by mentioning some other projects. Next slide. In which broadcast, excuse me, time for a little water if I might be excused. Yes, it's better. Broadcast group, communications group provided between them low-power transmitters and simple studios for local broadcasting. This was on request from local administrations who didn't have the resources or knowledge to provide such facilities for themselves. In addition, there was an exceptional requirement for a station in Rhodesia. Looking at some of these, Tristan da Cunha, a tiny volcanic island with an approximation with a population of about 300 souls, with a diameter of about 7 miles, volcanic. The only settlement is named Edinburgh of the Seven Seas, and I have never discovered why it was called that. Only a very low power transmitter was needed with a range of a few miles. In addition, 2 receivers for picking up the world service for relaying via the transmitter. St. Helena, a similar requirement. Turks and Caicos Islands, a small but reasonably sophisticated facility was provided, a transmitter and a studio. Dubai, back in the 80s, Dubai was but a very small dwelling when I first visited, but it was destined to become a mega city. In the earliest days, a member of CED's broadcast group was offered attractive employment terms to assist with this setting up of an early broadcasting facility in Dubai. This offer was accepted. And when I stopped over on the way to Madeira, I was met by my ex-employee with a very posh, large Cadillac. In November 1965, the Smith government of Southern Rhodesia made its unilateral declaration of independence. Wilson, the then Prime Minister, wanted a broadcasting station in adjacent Botswana to transmit BBC programs into Southern Rhodesia. He asked the BBC, Marconi, Cable and Wireless together with how long it would take to provide such a station. None of the replies was less than many months. But then Harold, of Aspidistra fame, came to the government's attention. Harold thought it could be done more quickly, so he was authorized to go ahead, and it became known as the Central African Relay Station. Harold rotated a 60 kilowatt medium wave transmitter made by Continental Electronics, which was available off the shelf. It was shipped to South Africa and thence by train to Francistown. Similarly for an aerial system. Initial installation was in an army tent. Harold negotiated the assistance of local prisoners for ground clearance. This is a prime example of what can be done when there is room for what might be called unconventional personal initiative, which is not hemmed in by bureaucracy. The first transmission was on air within 3 weeks of the authentication being given. The station eventually comprised 2 medium wave transmitters, 200-foot masts, receiving station, and ancillary equipment. There were lots of other small projects which deserve at least a mention, but there is no time to go into them in detail. In the 70s, there was another minor unilateral declaration of independence by Anguilla for the administration in Martinique in Caribbean. At the request of the Home Office, the DWS quickly put in a low-power local broadcast station to give local information and relays of BBC broadcasts. Other minor projects were carried out at Proba, which includes the installation of a small medium wave station in Malta, another for Tristan for the Trucial Oman Scouts in the United Arab Emirates, and one in Salalah, Oman in 1970. So those examples give I think, a very good overview of the hugely interesting jobs and work satisfaction which the broadcast group had. Right, finally, my final section, just a little bit on books. I'm going to suggest 1 or 2 other books for people who are interesting and going on. Next slide. Now, the most important one is by Sefton Delmer, who was the kingpin of black propaganda. In 41, and I am reading from my script now, Mr. Delmer was made a head of newly created section of the political warfare executive, charged with the task of spreading what became known as black propaganda. He started with a secretary and 1 assistant, but from these small beginnings, developed one of the most curious and fascinating products of the whole war. Now, this next bit is especially relevant and interesting. He was ideally suited to the task, as his pre-war occupation as a journalist brought him into close contact with Hitler and other high-ranking Nazi officials. Indeed, he flew with Hitler in his private aircraft many, many times. Knowing the enemy made it easier to formulate effective propaganda. So he was so successful that he was named in the Nazis' Black Book for immediate arrest after their planned invasion of Britain. My copy is particularly valuable in all senses of the world, as there's a handwritten note on the front cover, inside the front cover, which reads, "To one of the many good Germans, this cautionary tale of the machinations of a very wicked Englander. They, the Germans, hide their lights when it comes to choosing who shall lead them." That book is an absolute treasure. Then we see the Black Game. by Eric Howell. Now, this partly overlaps into Sefton's books, but it contains a lot of information about subversive activities. And I will give you just one example, and so you can decide whether or not it might be worth having a copy. A major aim was to hinder the German production of war weapons. One such method was, of course, the bombing of the Möhne Dam, thus depriving factories of electrical power. But far smaller schemes also had a very good effect. In those days, much machinery was driven by steam engines from coal-fired boilers. There were piles of coal near the boilers, and this was shoveled manually into the fireboxes. Rats made their homes in or around such piles because of the warmth. Rats were killed in the UK, and their insides were stuffed with a high explosive before being carefully sewn up. These were infiltrated into the coal piles by undercover agents. And I always say to them, what would have happened to those agents if they'd been discovered? The stokers shoveled the coal into the boilers together with the dead rats. The resulting explosions put a lot of plant out of service for a considerable time, which undoubtedly caused some annoyance to the Gestapo. There are hundreds of other fascinating stories like that in the Black Game. On the next slide, for those of you who are interested in wireless or history of wireless, this book was kindly given to me by Marconi and signed by all the people in Marconi who I had a contact with. I think that was very good of them, because I was not at all, they weren't at all happy bunnies when I asked for so many changes to the 100 kilowatt transmitter designs, but it makes good reading. Then on the next slide, The Secret Wireless War, which runs to 379 pages, is well worth reading, and it is worth spending a little extra for the hardcover version. Now, I should immediately chip in there that my copy, which great treasure, signed by Jeffrey, the author, but he died literally about 3 weeks ago, and at that time it was out of print. But I have gathered now through family that arrangements have been made to have another edition printed. To summarize the content would take many pages and would be well beyond the scope of this presentation. But do consider buying a copy. Then another book, which I only remembered after doing all the slides, with this one. Oh, I can't see that. Can you see that, David, most of it?
That's fine, yes. Edgar Harrison, yeah.
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 That book, Edgar Harrison, he was a wireless operator to Winston Churchill. And after the war, he became the principal signals officer of the diplomatic wireless service. Now, I finish off by making just one comment about well, a couple of comments, if I may be allowed to, about myself. All my Royal Signals postings had a good technical content, which as an ex-radio amateur suited me admirably. This included a 3-year external London BSc degree at the Royal Military College of Science, as David has already pointed out, on full pay, note, on full pay, no 30K to fine for tuition fees, and on full pay, absolute manna from heaven. Then my second career in the DWS was a perfect mix of management and hands-on volts, ohms, amps, and some mechanical thrown in. I was a very fortunate bunny indeed, with 2 such careers. So after that burst of euphoria, I will pass you back to our host and hope that there's been something in my presentation which is of interest to everybody. Back to you, David.
Thank you very much, Roger. Thank you indeed. Now then, at this point, if anyone has any questions that they'd like to ask Roger, please ask in the chat, sorry, I beg your pardon, in the Q&A box. If you ask the questions, I shall read them out and Roger will answer them. Okay, getting lots of comments incidentally. Superb, thank you. Somebody is saying, thank you, Roger. I'll just have a look at some of these, you might be interested. Fascinating lecture, superb, thank you. Thank you, gentlemen. Excellent presentations. Roger, thank you for a fascinating lecture. Looking forward to viewing again and recording. Fascinating lecture, nice to see a couple of old colleagues on here from Crystal Palace. Thank you, yes. Yes, all sorts of comments. So thank you very much, everybody, for your very kind comments. It is very, very kind of you. It really is very decent. Now at this point, I'll have a look at the Q&A. I'll have to change my glasses, I'm afraid. So what do we say? Somebody is saying, will the recording be available somewhere? I can answer that, yes, there will. Question here from John. I remember a studio at Aspie. Was it ever used? Roger?
Sorry, I didn't, was that a question? I didn't.
Yeah, sorry, I'll ask, I'll say again. From John, I remember a studio at Aspidistra. Was it ever used?
I knew that in my antiquity of 87 years, that I might have difficulty in understanding 1 or 2 of the questions. Can you try again on that?
Yes.
What about?
Yes. John is asking, he seems to think that there was a studio at Aspidistra, and was it ever used?
Oh, right. Okay. Right. All the production of the black propaganda by Sefton Dilmer was up near Wadden, which is described in that book by Harrison. So there was no studios at all at Crowborough, but it was all done from the Wadden area, where during the war, parts of the PWE, political war executive, was housed in great secrecy.
Right, okay. Question here from Keith. How many of these sites are still in use? I was at Madeira in 1972, so how many of the broadcasting sites are still in use? Is Madeira still in use, for example?
Right, I'm afraid that I can't answer that completely with any accuracy, because that was obviously long after I had handed over to the BBC. I do know for certain that the medium waves, let me get this right, the shortwave station in Cyprus closed, and there were some very unhappy pictures on the internet, unhappy for me and all my staff of the station being broken up. And I know that the medium wave station at Ladies Mile stayed on the air for a while, but I don't know for how long. Orford Ness closed, and after it was closed, and I can't remember the date, but it was taken on by the Netherlands, or borrowed by the Netherlands, because they had a big fire at one of their domestic stations, and they used the 648 transmitter for the domestic purposes. And then after that, Radio Caroline came into the picture, and they were at Orford Ness for a time, but they then moved on to some land-based station, and I can't remember where that was. The latest I have got in Madeira is that Madeira closed and the operation was transferred to the mainland. And that used a French Thompson transmitter. And it was, to the best of my knowledge, the first 600 kilowatt transmitter, which was all solid state. And that employed, and I can't remember the details, but a very large number of much lower powered power amplifier modules, which were hot pluggable in the event of a in the event of a fault. Crower completely closed and was turned over. I can't remember the details, but it was something to do with training headquarters for the police or something akin to that. So not a very precise answer, but that's the best I can do.
Okay, thank you. Question from Steve. Were any of these sites used for number stations? These are the sites that would broadcast groups of 5 numbers. I somehow don't think they were, but what do you think, Roger?
Sorry, I didn't get that.
No, it's okay, it's all right, don't worry. Were any of these sites, transmitting stations, used for number stations? You remember the number stations would transmit groups of 5 numbers? No?
No.
No, okay, don't worry, that's all right. We'll go on to another one then. It's all right, don't worry. Great lecture, says Martin. Anything on receivers utilised like AR-88s or Rayco RE-17s, 1972, etc., at the various sites? So Martin's wondering about the receivers, the shortwave receivers that would be used at various places, like Madeira or Cyprus, for example.
Yeah, you mentioned 2 receivers, both of which were used. The Rayco receiver, which was also used on the my communications group for a very long time, and the AR-88, and anybody who's only been near that radio will know all about that very famous receivers. And later on, there was a very, I can't remember the type number, a Plessy receiver, which was all digital after the first RS amplifier. So those are the only 3 receivers which I'm aware of.
Okay, so thank you. Now here's an interesting question from Richard. How much of a problem was there to provide providing a dummy load for Aspidistra and getting rid of the heat? So if Aspidistra were to, instead of being connected to its antenna, were to be connected to a dummy load, how would the dummy load be cooled?
Sorry, how was it cooled?
Yeah, how would, if Aspidistra was connected to a dummy load, rather than the antenna connected to a dummy load, a big resistor in other words, how would it be cooled?
The answer to that is, I've got to be absolutely honest, I don't think I ever knew.
Okay, thank you very much, Roger. Thank you.
I've got to be honest. No, yeah. I'm not going to guess when I don't know the answer.
No, of course not. Absolutely. That's fine. Great. Thank you. Thank you. Another one here. There's various questions, everybody. We'll try and fit in what we can. Roger, you comment on the different transmitter manufacturers. How much clout did you have in selecting the best equipment as needed against fighting the accountants? Also, could you comment on
against fighting
the accountants?
So the assemblants?
The accountants. The people that did all the paperwork, basically, the bean counters, you know. Yeah.
So we're talking about any difficulties associated with
with selecting the best equipment.
Ah, okay.
Yes, yes. I mean, were you fighting bureaucracy?
Bureaucracy, right. Okay, thanks. Yeah. And be careful what I say here. Yes, I think it is far enough down the line for me to tell 2 stories, which will answer that question quite nicely. When it came to choosing the AEG 648 kilohertz transmitter, Marconi hadn't got anything to offer. When it came to choosing the 4 new 100 kilowatt transmitters for Cyprus, I was very keen indeed to go for AEG shortwave transmitters, partly because we were so pleased with the medium wave transmitter. And also we went to see them in Germany, and also went to see them in, I think it was the BBC Rambersham site. They were absolutely superb. So what happened? Why did I wind up with Marconi? Well, I have said Lord Weinstock decreed that Marconi should redesign according to what I favoured. But when I was at Marconi with 2 of my staff discussing something which was nothing whatever to do with the Cyprus transmitters, Lord Weinstock walked in, offered his hand to me, offering a handshake. Now, I had never seen Weinstock before, so he must have been briefed from where I was sitting. And he said, Roger, can you remember how much AEG have quoted you for transmitters? I said, well, I can't possibly tell you that because that would be going against the general agreement and trades and tariffs, etc., etc. So he took his notebook out and he said, I will tell you. I will tell you. That must have been the biggest commercial espionage that I've ever encountered. I don't honestly believe it was any of my dedicated staff. So how it happened, I don't know. But then Marconi hierarchy approached the DTI, and the head of the DTI demanded that they have a meeting with the Foreign Office, at which I was present, the Foreign Office Minister. I can mention his name quite safely, it's a long time ago, Douglas Hurd, awfully nice chap, and various others. So we were waiting for the head of the DTI to come in. He was very, very late, and he started expounding how on earth could a member of the Foreign Office only associated with diplomatic matters, how could they possibly say that they wanted one transmitter rather than another sort? Hurd held his finger up to his lips while he was speaking to me, while the DTI was speaking, as if to, Roger, shut up, don't say anything. And when he finished, Hurd said, I will now introduce you to Roger Castlesmith, who's a chartered engineer, etc., etc., etc. The head of the DTI walked straight out, saying absolutely nothing. Foreign Office 1 point, DTI 0 point. And it was only because Weinstock had insisted that their staff redesigned the transmitters to my liking that we didn't wind up with AEG shortwave transmitters. So that is a perfect example of what one was up against, that there were others, but let's not, I think that's adequate to answer the question, was there any bureaucracy? You've heard some of it.
Good. Thank you very much, indeed. Lots of comments coming in. Thanks to Roger and David for an intriguing evening. All sorts of things. Ladies' Mile is still open. Radio Caroline uses the spare 648 mast at Beaufort Nest and is looking to increase power, as spotted recently. But back to the questions. Terry Hart says, thank you for a fascinating presentation. Could you tell us about the earth mat arrangements for the low frequency antenna installations, especially in the sandy areas? So talking about, so think of the antennas and the earth mat in the sandy areas, you know, in Mazier Island, for example.
Right.
Were there any problems with it?
Right. I'm just going to hop back to Cyprus for a minute. Very sandy where the medium wave aerials were. And there, we had a huge and extensive ground mat system. And when one was walking around the ground, they were almost impossible to see. But what was fascinating was that aerial photographs showed that ground mat, the radials from the ground mat, almost as if they had been drawn on the sand. So it just showed what could be gleaned from aerial reconnaissance during the war. And then in Madeira, where we got a driven array, director and a reflector, the whole area was sodden with seawater. And it is my belief that there was no ground plane thought to be necessary. Not 100%, that's the best I can do.
Okay, thank you very much. Now, time's getting on, everybody. It's now 9:30. Just one last question, and it's an interesting question from Roger. And Roger says, I was once told that ASPI-1, Aspidistra, could be hand-keyed to send CW in the event of World War III or a similar disaster. Is there any truth in that story? Could it be hand-keyed to send Morse code?
The answer was yes, it could be keyed, but I am not aware, and I'm looking at the books concerned, and of course having some of the wartime station staff, which was still just serving when I arrived, I'm not aware of any incidents when it was keyed for Morse code.
Okay, thank you very much. Right, okay, everybody, it's now 21:34. Time is moving on. And we've been here since 7 o'clock. I'm going to change my glasses again. So, as I said earlier, I'm going to write to everybody and I'll send you all a CPD certificate. And also, if you have any further questions you would like to ask Roger or ask things in depth, get more information, please send an email to me and I will send it on to Roger and we will come back to you. So, great, excellent. So we've had a considerable number of people online this evening, and judging by all the comments, there have been a huge number of comments in the chat, people saying thank you, people talking amongst themselves, all sorts of interesting information. Great event, says Ian, fascinating, thanks. All sorts of things. So anyway, Roger, thank you very much for this evening's presentation. And really, when I asked my question 48 years ago, what is Aspidistra? I could never, ever have imagined that my question would be answered all these years later in such an in-depth and interesting manner. We've learned a lot tonight, Roger. We've learned about Aspidistra. We've learned about black propaganda. We've learned about Cyprus, Madeira Island. We've learned about different modulation techniques, antennas, switching antennas, all sorts of things, program feeds, many, many items. And as one or two people have pointed out, we've only just touched on the big story. There's an awful lot more, which of course we have no time to hear about this evening. So everybody, we've learned a lot. And I think the most important thing is that we've been very privileged this evening, very privileged indeed to meet Roger and to hear just a few of the many stories he has to tell. I've got to know Roger very well over the last few weeks and few months as we prepared this talk. And I'm hoping, Roger, to keep in touch with you as time goes on. And we've swapped many interesting stories. So that's us for the evening, everybody. Thank you, everybody, again. And I also have to say thank you to my colleague, Mike Farnworth, for providing the artwork for the interval and the opening and closing sequence. Thank you very much, Mike. Anything else I have to say? No, that's great. So once again, if I could also ask you, please, to fill in the feedback form, which the IET will send you in the next day or so. We're very, very keen to hear feedback from you. Positive comments and negative comments, we welcome them all. Okay, so at this point, I will say good night to everybody and good night, Roger. We'll keep in touch, yes?
Good night. And
Good night. Thank you.
I would say that we probably want to chat a little bit. It's too late tonight, so let's have a little chat tomorrow morning or tomorrow.
Okay. Yeah, we'll do that. I'll be in touch, Roger, and we'll set up a meeting, yes?
That's excellent.
Okay, then, so I'm going to run the closing sequence now, so it'll take a few seconds again to set this up, and I hope I get it right this time. Just wait and see. Hold on.
Thank you.